In bonds, and two things you really have to do with a bond now. You have to know how to value the bond, and you have to know how to calculate the yield on the bond. And in this problem it reads, Complex Systems has an outstanding issue of $1,000 par value bonds with a 12% coupon interest rate. The issue pays interest annually, has 16 years remaining on its life. The A part says, if your required return, your yield and maturity were 10%, what would be the value of the bond, the price of the bond? Now, to value a bond, we use what's called the bond pricing formula. And the bond pricing formula, like all valuation models really, they tell us that the value of any asset today is the present value of all future cash flows. Recall with a bond now, you have two kinds of cash flows. You have an annuity, which is the periodic payment of interest, and you have a lump sum cash flow, which is the face value of the bond at the end of the life of the bond. So as you look at the bond pricing formula, it's saying that you need to find the present value of the annuity and you need to find the present value of the lump sum on the bond. Now, as is always the case when you have a bond, if they tell you what the yield is, they want you to calculate the price. If they tell you what the price is, they're going to want you to calculate the yield. It goes back and forth. For this particular bond now, the annual interest that you'll get in dollars is the face value of the bond, $1,000, multiplied by the stated return on the bond, 12%. So 0.12 times 1,000 gets you $120. That's how much interest expense you'll get every year for 16 years. That's an annuity. How do you find the present value of an annuity? You multiply by your PVIFA. N's equal to the number of payments, which is 16. I equal to your required return, your yield that you're looking for on the bond, which in this case is 10%. The other cash flow is a lump sum cash flow you get at the end of the life of the bond. And that's going to be $1,000 that we get 16 years from now. And we require a return of 10% per year. Well, to find its present value, you take the value of the lump sum cash flow and multiply it by your PVIF at 16 and 10%. If you add up the value of the annuity, add it to the value of the lump sum cash flow, you find that the value of the bond is $1,156.44. As an investor, if you invested $1,156.44 into an investment today, and from that investment you got $120 every year for 16 years, and then a lump sum cash flow 16 years from now of $1,000, your rate of return on that investment would be exactly 10%. If you want to do this on a calculator, you would set your payment key equal to $120. You would set future value. That's the lump sum cash flow you're going to get, which is $1,000. N's equal to 16. I is equal to 10 or 10%, that's your required return or your yield on the bond. Have your calculator solve for present value and you get $1,156.47. Other than a little rounding error, exactly the same answer. The B part to this problem says, what is it that could be making this bond change value, that makes its price go up or down? Well, there's two things that could be at play here. One, the company could be changing kind of its internal financing. It might be taking on more debt, less equity, but the risk of the company might be going up and down, changing. The other thing is the market itself. You might have interest rates, Federal Reserve policy, driving interest rates up or down, and that would make the value of the bond also go up and down. That's the answer to the B part. In the C part, they said, what if you required a 12% return? That is, what would you pay for the bond if the yield on the bond were 12%? Well, as we said in one of the lecture videos, anytime the stated return on the bond and the yield to maturity on the bond are the same, the price of the bond is always the face value of the bond. So if you required a 12% return off a 12% bond, you'd be willing to pay face value or $1,000.